Yet another question of JEE 2020. The question is about a functional equation f from R to R and g to R to R be satisfying these two equations. If I look at the first functional equation, f of x plus y plus is equal to f of x plus f of y plus f of x into f of y. So what I do is I add 1 on both sides, and I simultaneously see that this gets factorized. This is 1 plus f of x into 1 plus f of y, which is equal to 1 plus f of x plus y. Now if I call this 1 plus f of x as some function p of x, so this is p of y, and the left hand side is p of x plus y. This is one of the primitive functional equations which, when used by the concepts of derivative, you come to know that the functional equation is a to the power x. How do we get this? If you wish to do, although this is an objective type fast track paper, but p dash x would have been written as p of x plus h minus p of x upon h. P of x plus h with this equation would have been p of x into p of h. So if you take p of x common, this becomes p of h minus 1 upon h. Now this basically is a constant with respect to x. So you get dp by dx is equal to some constant times p. When you do the differential equation, this is ln p is equal to some constant. So p is equal to some constant raised to x. Now if I use this thing, I simply get f of x plus 1 is equal to a to the power x. So f of x is equal to a to the power x minus 1. If you look at gx, you get gx is equal to a to the power x minus 1 upon x. But you have been given that limit x tending to 0, g of x is equal to 1, which is sufficient to conclude that a is equal to e, because this is the basic limit e to the power x minus 1 upon x is equal to 1. So you get both of your functions. Now if we start looking into the options, the first one says that fx is differentiable for every values of x, which obviously is correct because this is directly a function. If g of 0 is 1, now if I see that gx is not defined for 0, but if g of 0 is 1, then the limiting value of g of x at 0 is 1, so the function is continuous. Otherwise gx is throughout differentiable, so this becomes correct. The derivative of f dash of 1, so let us quickly see what is f dash of x. F dash of x, a already is e, is basically e to the power x as such. So at 1 will not give a value equal to 1, but at 0 will definitely give a value 1. So the correct answers are A, B and D.